Hi, this is Mike, and today I wanted to show you a new feature that's recently added to the ROMulator. It's an external virtual display in a web browser that you can use with certain 6502 machines when you have the ROMulator connected to a Raspberry Pi. And here you see we have a Commodore PET 2001, and we have a virtual display in a web browser along with the regular CRT. It doesn't work exactly the same as RGB to HDMI or something that samples the actual video out. What we're doing here is we are copying video RAM images from the ROMulator to the Raspberry Pi while the CPU is running without needing to halt the CPU. The basic functionality of the ROMulator lets you replace RAM or ROM in a 6502 machine. You can also halt the CPU and download the contents of memory for debugging purposes. You can also upload memory while you halt the CPU. But in order to do this virtual display, what we've done is added a dual-ported section of RAM that I'm calling VRAM, or video RAM. And what dual-ported means is that instead of the usual way that RAM works, where you have a single address bus and data bus, and you can normally only read or write a single byte at a time, in dual-ported RAM you can simultaneously read and write for different addresses, and you don't have to halt the CPU while it's happening. So we're repeatedly sending the contents of video RAM over from the ROMulator to the Raspberry Pi and running a web server on the Raspberry Pi which sends RAM images, and in the browser it's using the character ROM to convert those to images of the screen. In the configuration file for the enable table we can specify certain regions as VRAM, and here for the Commodore PET we're using 8000 hex to 83FF hex, which is the region that the character information is stored on the PET. We currently have a maximum size of 2048 bytes that we can use for VRAM. That can be increased if needed. To use the virtual display, first we will hook up the ROMulator to the Raspberry Pi, and we're going to reprogram it with a updated image with new VRAM regions. So we just hook up the ribbon cable here, make sure that the jumper is on so you're getting power from the Raspberry Pi to the ROMulator, and then we go ahead and build the ROMulator image. In this case I'm actually building on a PC and copying it over to the Raspberry Pi rather than building it directly on the Raspberry Pi. The Raspberry Pi 0 and 0W don't directly support the open source toolchain of the FPGA on the ROMulator, so in this case I'm just building it on a PC. Then we flash the updated firmware onto the ROMulator. We have the ROMulator installed with the CPU and the PET motherboard now, connected to the Raspberry Pi with the jumper off. And then we start up the machine. See the light blink on the ROMulator. And we boot up to BASIC 4.0 on the PET. Starting a web server on the Raspberry Pi, which will allow you to retrieve VRAM images from a running machine. And we point the browser to the Raspberry Pi's web server that's running. And we get our virtual PET display. Every time you retrieve a video RAM image from the Raspberry Pi, the browser itself is running a JavaScript program which takes that video RAM image and using the contents of the character ROM converts it into a bitmap that can be displayed on the screen. We're going to load up Space Invaders here so we can get a little bit better demonstration of the video output here. And there you go, we're running Space Invaders on both the CRT and in a web browser for the Commodore PET. And we're getting about 20 frames a second, give or take a few. This will vary depending on how large your video RAM section is. That's the only data that's being transferred between the Raspberry Pi and your browser. So it can run at a fairly high frame rate. The conversion from those video RAM regions into bitmaps is happening in the browser in JavaScript using the character ROM binary. The feature is still under development, and for the moment it only supports the Commodore PET 2001. In the future it will be possible to create other virtual displays for other 6502 machines that have memory mapped graphics like the PET does, but it will require a little bit of extra development to support those. More information on how to use the virtual display function will be available in the GitHub repository for the ROMulator. I hope you enjoyed watching this little demonstration.